Hello and welcome to IP Lesson. In this lesson, we will learn about Classful IP version 4. IP version 4 stands for Internet Protocol version 4. IP version 4 consists of 32 bits. The total available IP addresses for IP version 4 is 4,294,967,296. So if we calculate 2 power of 32, it will give us this number. So writing the IP address using the bits are very complicated. For that reason, most of the switches and the routers are using something called dotted decimal notations, and the dotted decimal notations used to make the IP address string easily. So instead of typing the IP address on bits, we can use the dotted decimal notations and the IP address will be similar to this one. So in our example here, we have 124.1.1.1. This is the IP address in dotted decimal notations. So the IP address now have 4 octets. Each octet represent 8 bits. So 124 represent 8 bits, and then there is dot, and the one represent 8 bits, and there is another dot, and this one represent 8 bits also, and there is a dot after the one, and the last one represent also 8 bits. As you can see, the IP address written in dotted decimal notations much easier than the IP address written in the bits. We spoke before about the encapsulation process, and we mentioned that in order to send the data, we should have the source IP address and the destination IP address. The IP address is a layer 3 address. First and the most important thing in order to learn about the IP address is the subnetting. Subnetting is the strategy used to partition a single physical network into more than one smaller logical subnetwork, and the subnetworks is the subnets. So subnetting similar to the VLAN. The VLAN segments the LAN to more than one VLAN or virtual LAN, and the subnetting is segment the physical network into more than one subnetwork, and we can refer to the subnetworks using the subnets word. Subnetting will divide the IP address into 2 portions. One portion will be the network address, and the other portion will be the host address. So in our example here, we have the IP address 192.168.1.1. We can use the subnetting and split the IP address to network address and the host address. In our example here, we have 192.168. This is the network address, and 1.1 is the host address. So the network address is used to find the subnet in which a computer or the device is located. The host address used to find the computer or the device in the subnet. So you can think of the network address as the subnetwork address, and the host address is the IP address of the device. We will learn more about the network address and the host address in the coming slides. So let's ask a question here. Which part of the IP address will be the network address, and which part of the IP address will be the host address? Should we choose 8 bits as the network address and the rest of the address be the host address? Or should we choose 16 bits as a network address and 16 bits as the host address? So for subnetting, we can use one of the 2 methods. We can use the classful subnetting, or we can use the classless subnetting. For today, we're going to speak about the classful subnetting, and the classless subnetting will be on the next video. So classful addressing is an IP version 4 addressing architecture that divides address into 5 groups. Each class of the IP address is used to determine the bits used for network ID and host ID and the number of total networks and hosts. Let's take a look at our table here in order to understand more about the classful. So as we can see, the classful divides the IP address into 5 groups. We have class A, class B, class C, class D, and class E. Each class have a range So for class A, we have the range from the IP address 1.0.0.0 up to 127.255.255.255. So for class A, we can assign the IP addresses from IP address 1.0.0.0 up to 126.255.255.255. We cannot assign the IP address 127.0.0.0 up to 127.255.255.255. And the reason of that, because this range is reserved for loopback. Class A used for large size network. The prefix of Class A is /8. Class A have 126 networks, and the total hosts number per network is 16,777,214. Class B have the range 128.0.0.0 up to 191.255.255.255. Class B used for medium-sized network. The prefix is /16. The total networks is 16,384. The total host number per network is 65,534. We have Class C. Class C have the range 192.0.0.0 up to 223.255.255.255. Class C used for small size network. The prefix is /24. The total networks is 2,097,152. The total hosts number per network is 254. Then we have Class D. Class D have the range 224.0.0.0 up to 239.255.255.255. Class D used for multicast, and the example of using the Class D is for audio and video stream. And we have also Class E. Class E have the range 240.0.0.0 up to 255.255.255.255, and the Class E is reserved. So the classes that we're going to talk about today is Class A, Class B, and the Class C. Since the Class E is reserved, we will not talk about it, and the Class D also used only for multicast. So we will learn about the multicast in another video. But for today's video, we want to focus in Class A, Class B, and Class C. Let's start with the prefix. So prefix length specifies the number of bits in the IP address that are being used as a network address. So the prefix in general specifies the bits that are used for network address, and the rest of the bits in the IP address will be the host address. For example, in Class A is a /8. /8 mean that 8 bits are being used for the network address, and the rest of the bits are being used for the host address. Class B, for Class B, the prefix is a /16, which means 16 bits are being used as a network address, and the last 16 bits are used as a host address. For Class C have the prefix /24, and this is mean the first 24 bits are being used for network address, and the last 8 bits are used for the host address. So for Class A, the first octet are being used as a network address. For Class B, the first 2 octet are being used as a network address. And for Class C, the first 3 octet are being used as a network address. Let's explain more about the network address. And by the way, the network address is the same as the network ID. And you can tell from the name, it's the ID of our network. So let's take a look at our example here in order to understand the network address more. In our network, we have switch 1, router 1, and router 2. Switch 1 have 2 VLANs, IT VLAN, and HR VLAN. So we need to assign IP addresses to the IT VLAN, the HR VLAN, and the link between router 1, router 2, and the link between router 2 and our internet. For the link between switch 1 and R1, This link needs a special configuration, and we will talk about this later. So in our example here, we will follow the classful subnetting. We need to assign the IT VLAN a subnetwork, and HR we need to assign it also another subnetwork. The link between R1 and R2 need to be in a different subnetwork, and the link between R2 and our internet access need another subnetwork. So you can ask a question here. Why the link between R1 and R2 need a subnetwork? And this is the answer for this question. So by default, for our switches, the switch interfaces should be in one network by default. The reason of that, because the switch ports are assigned to VLAN 1. Every single VLAN that we will create in our network should have a dedicated subnetwork. And for our routers, by default, each single interface in our router should be in a different network. For example, if we have a router with 4 interfaces, interface G1 should be in a network, interface G2 should be in a different network, interface G3 should be in a different network, and interface G4 should be in a different network. Let's continue with our example. So in the IT VLAN, we have 20 devices. For HR VLAN, we have 30 devices. For the link between R1 and R2, we have 2 devices. We have this interface on router 1 and this interface in router 2. And for this link, we have also 2 devices. One belongs to R2 and the other device belongs to the internet or ISP. So as you can see, our network is very small, and we can use Class C for our network. So we can pick up any subnetwork from Class C range. For example, we're gonna choose the network 192.10.10.0/24. This subnetwork, we will use it for the IT VLAN. For the HR VLAN, we're gonna use 192.10.11.0/24. And let's ask a question here. Should the subnetworks that we will pick up from Class C should go in order? And the answer is no. So we can choose another subnetwork from the same range, but it shouldn't go in order. For example, for the link between R1 and R2, we picked up subnetwork 192.10.50.0/24. And for the link between R2 and our internet, we will choose the network 192.10.12.0/24. So let's ask a question here. Why did we choose Class C for our network? Why didn't we choose Class A or Class B? So first of all, Class C is made for a small network. Each subnetwork at Class C can give us 254 hosts, so we can have up to 254 devices. That's why Class C made for a small network, and also we are trying to make our network as much closed as possible for a security purpose. So Class C have the prefix /24 as we spoke before, and the range for Class C is from 192.0.0.0 up to 223.255.255.255. We need to focus on the network address, so the first 3 octet, in order to calculate and learn how the 2,097,152 subnetwork came from. So let's understand how Class C give us those subnetwork. So it's a /24, as we mentioned before, first 3 octet. So in Class C, we can see the subnetwork 192.0.0.0, 192.0.1.0, 192.0.2.0, 192.0.3.0, 192.12.3.0, and this will be up to the subnetwork 223.255.255.0. So to calculate the subnetworks, so first of all, we will say 224 minus 192. It will give us 32. This is for the first octet. Times 256 times 256. So the first 256 for the second octet, for this octet, and this 256 for the third octet. So the highest number can be on one octet is 255, but please keep in mind that we count the zero. So as you can see here, we count the zero, and also in this octet we count the zero. So 0 will be the first subnetwork, then 1 will be the second subnetwork, then 2 will be the third subnetwork up to 255. That's why we have 256 here and 256 here. So it will be 32 times 256 times 256. It will give us 2,097,152 subnetworks. So if our network is a small network, we can pick up any subnetwork from the class C. So we can pick up 2 subnetwork, 3 subnetwork, whatever we want based on our network. And as we mentioned before, class C is suitable for a small network. So we can pick up any subnetworks that we need from class C and assign this subnetwork to our VLAN, for example, to a network at our router, to our servers, or to our virtual machines. So it all will depend on our network. After we learn about the network ID, we need to take a look at the host ID. So the host ID or host address used to find the computer or a device in a subnetwork. So in our example, we use the subnet 192.10.10.0/24 for ITV-LAN. Any device on the ITV-LAN should start with 192.10.10, which is the host address, and .2 is the host ID. And for the host address, it can be anything. So for the host address, we have from .1 up to .254. Anything from that range will be on the ITV-LAN. So right now, this device on the ITV-LAN, so if you are a network engineer and you work in a company and they have an ITV-LAN similar to our example, and the ITV-LAN have the subnetwork 192.10.10.0/24, and your PC have the IP address 192.10.10.2, you can also identify your IP address like this. You can say, I am on the ITV-LAN and my IP address is .2. All your team member will know right away that your IP address is 192.10.10.2. The reason of that because the ITV-LAN have the network address 192.10.10, and when you say 2 refer to the host ID. So you will hear a lot of engineers talk like that. They don't mention the full IP address. They just mention the host ID. So back to our example, let's continue with the ITV-LAN. So on the ITV-LAN, you can also find a computer or a device with the IP address 192.10.10.3. So let's focus here. Can we find on the ITV-LAN the IP address 192.10.2.4? And the answer is no. The reason of that, because the ITV-LAN have the subnetwork with the network address 192.10.10. So 192.10.2 considered as another subnetwork and cannot be on the ITV-LAN subnetwork. So for HR, we assign the IP address 192.10.11.0/24. Inside the HR VLAN, we can find the device with the IP address 192.10.11.1. Inside the HR VLAN, we can find any IP address on the same range, and the last IP address should be 192.10.11.254. So the host ID at the HR VLAN start from 192.10.11.1 up to 192.10.11.254. So that 254 is the last IP address. And if we have more VLANs or network, we still can use the other subnetworks from class C. It depends on how small or how big is our network. So let's calculate the host address for class C and see why class C give us 254 hosts. First of all, the host's address is 8 bits, which mean 24 bits for network address, which is the first 3 octet, and 8 bits for host address, which is the last octet. So let's expand the last octet in order to see the host's address. So the last octet is 8 bits. So we mentioned before that the bits are just 0 and 1. So if we have 2 bits, what is the possible numbers that we can find for bits? So the possible numbers will be 0, 0, 1, 0, 1, 1, 0, 1. So the 2 bits give us 4 possible numbers. If we add another bit, it will give us 8 possible numbers. So it will give us those 4 possible numbers one time with 0 and one time with 1, which mean 4 times 2. So each bit we will add, we will multiply by 2. So the third bit give us 8 numbers. The fourth bit will give us 16, 32, 64, 128, up to 256 for 8 bits. So the 8 bits give us 256. So the total is 256 number, and the IP address start from 0 up to 255. So at the IP address we count the 0. The 0 is a number. That's why the highest number we can see at the octet is 255. Let's pick up a subnet from class C to see the host's address. So I have picked up the subnetwork 192.0.1.0/24. So as we mentioned before, class C give us 254 hosts per network or per subnetwork. And we said that the 8 bits will give us 256 numbers and the IP address start from 0 up to 255. So for the host address, the first IP address, which gonna be 192.0.1.0, this IP address cannot be assigned to any device, and this IP address represents the name of the network. So this first IP address we'll call the subnet number or subnet ID or network ID, and we cannot assign it to any device. So the 256 minus 1, which is the first IP address. So the left IP address will be from IP address 1 up to 255. So the last IP address cannot be assigned also to any device, and this IP address will be the broadcast for this network. So you can call it subnet broadcast or broadcast address. So the broadcast address, which is 192.0.1.255, cannot be assigned to any device, and this is the broadcast for this subnetwork. So as we mentioned before, the broadcast one sender to all possible receiver. If we want to send data to all the subnetwork, we can use the broadcast address. So the left IP addresses is from 1 up to 254. That's why in class C we have the total hosts 254. Let's do the same calculation for class B. Class B have the range 128.1.0.0 up to 191.255.255.255. Class B have the prefix /16, which means 16 bits represent the network address. So 16 bits will be the first 2 octet. Inside class B, we can see the subnetwork 128.1.0.0, 128.2.0.0, 129.3.0.0, 140.4.0.0, 170.5.0.0, up to the subnetwork 223.255.0.0. to calculate the total subnetwork for class B, we're gonna calculate 192 minus 128. It will be 64. 64 times 256. It will give us the total subnetwork for class B, which is 16,384. For the total hosts number, we can calculate it. So 254, which is the total hosts for one octet, times 254, the total number will be 65,534. Or we can calculate it by the bits number. So the 8 bits give us 256, 9 bits will be 512, 1024, 2048, 4096, 8192, 16,384, 32,768, and lastly, the 16-bit will give us 65,536. So 65,536 minus the broadcast ID minus the network ID. So the total hosts will be 65,534. So the classful subnetting is little bit old and it's rarely used nowadays. But subnetting in general will depend on our company, our networks, and the size of the networks that we need. So as we mentioned before, Class C is used for small networks. Networks have 254 devices or less than this. And for Class B used for a medium size of network. And the Class A give us the biggest size of subnetwork, and it's suitable for large companies. Let's take another example in order to understand more about the subnetting and the classful IP address. In our example here, we have one router. The router interface G2 connected to VLAN 2, router interface G3 connected to VLAN 3, router interface G4 connected to VLAN 4. So let's use the classful subnetting in order to assign IP addresses to those VLANs. First, for VLAN 2, we have 254 hosts. So since VLAN 2 have 254 hosts, we can use Class C because Class C can give us up to 254 hosts. So for VLAN 2, we picked up the subnetwork 192.0.0.0/24. We can pick up any subnetwork in Class C range. It doesn't matter. For that subnetwork, the first IP address, which is 192.0.0.0, this will be the network ID, and this IP address cannot be assigned to any device. Actually, our router will use the network ID as a name for that subnetwork. So the IP address 192.0.0.0 will refer at the router to VLAN 2 subnetwork. Then we can assign to our devices any IP addresses at this range. So IP address .1, .2, .3 up to 254. The IP address 192.0.0.255 cannot also be assigned to any device because this is the IP address of the broadcast address. For VLAN 3, we're gonna use also a subnetwork from Class C. Also, it doesn't matter any subnetwork. In our example, we use the subnetwork 192.0.2.0/24. The first IP address will be 192.0.2.0. This will be the network ID, and then for our devices, we can use any IP addresses in that range. It doesn't matter also, we don't have to follow the order. So we can use the IP address .1, .20, .50, .200, any IP address in that range. Also the last IP address, which is 192.0.2.255, cannot be assigned to any device because this is the broadcast address. Next, for VLAN 4, we will use Class B. VLAN 4 have 65,000 hosts, and the Class B can give us up to 65,534 hosts. We can also pick up any subnetwork on Class B. In our example, we picked up the network 128.1.0.0/16. Class B is a /16. The first IP address will be 128.1.0.0, and this IP address will be the network ID. For our devices, we can assign any IP address in that range. So we used the IP addresses 128.1.0.1, 128.1.1.1, 128.1.2.1, up to the IP address 128.1.255.254, the last IP address, which is 128.1.255.255, will be the broadcast address and cannot be assigned to any device. This is the end for this video. If you like my videos, please like, subscribe, and share. Thank you for watching and see you in the next one.